Hello, beautiful nerds. My name is Monty Paulson. I lead the Passive House team at RDH Building Science. I'm happy to see you. It's my privilege to welcome all of you to the Global Passive House Happy Hour hosted by Passive House Accelerator. This is an inclusive gathering. We welcome people from all Passive House communities. We welcome people interested in electrification, in embodied carbon, in climate adaptation, in indoor air quality. And oh yeah, that little job of retrofitting 6 billion buildings in our lifetimes. So please turn on your cameras. We want to see you. Please turn on your microphones for a minute. We want to make some noise together. And join me in a toast to what our dear friend Harold Orr called chainsaw retrofits, in which you have to saw off part of the building to save the building.
Cheers.
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 Cheers. Cheers. Cheers. I have a chainsaw.
Go.
All right, now mute your mics, close that other app. You're not going to need it for half an hour. We have an amazing show tonight, anchored by Martha Campbell and Amy Egerter. I hope I'm mispronouncing that, not too bad, of Rocky Mountain Institute. But first, let me introduce my co-host, Prudence Ferreira.
Thanks, Monty. Hi, everyone. Prudence Ferreira here, coming to you from Philly. I lead the zero carbon and passive house practices for Morrison Hirschfield. We've got 22 offices in Canada and the US. And I work on both US and PHI projects, pilot projects. I'm on the ASHRAE 227 committee that is figuring out how to bring a passive house-based zero carbon standard into the world. And I just love this community in the Passive House Accelerator because we all can share lessons learned and best practices and bright ideas and inspirations, no matter what standards we're using, no matter where we are in the world. And thank you all for being here. Here in the US, as partisanship and politicizing economic stimulus for the economy causes continued delays in bringing aid to sectors of the US workforce who most need it, more people in the US are experiencing what it means to be low income. And in fact, I think that's happening all over the world. Perhaps what will come out of this crisis is more compassion from all of us for those who struggle with their economic circumstances, even without the added pressure of COVID. And according to the Brookings Institute, vulnerable workers are disproportionately young, female, and possess less formal education. So as we experience increased disruption of business as usual from climate change, societal resilience is going to become increasingly important. And one very key way we can support this in the building industry is by reducing the percentage of people's income that needs to be spent on housing and utilities. So what if there was a group that could catalyze the zero carbon residential revolution, bringing better performing, safer, more comfortable, better indoor air quality homes for families, while spurring wealth and job creation in communities across the country, especially those that have been economically left behind? What if there was an initiative that, by combining demand aggregation and supply chain coordination, to bring high quality prefabricated mass scale retrofit packages that are easy to install and financed through utility cost savings existed? That group is with us tonight, and they have a message for the general public that they would like to share with us and get our opinion on. We're going to hear all about the juicy technical details later. But for right now, I'd like for you all to pretend that you're not PH enthusiasts or building science geeks. Think about your neighbors, your family, your friends. And as you watch the video that we have for tonight, let us know what you think. And you can put it in the chat. We can talk about it after in the breakout groups. But this message is for the general public, and we're just thrilled to share it with you.
Imagine easily upgrading our buildings so that they perform better for us. Quieter, cleaner, more comfortable, and no surprises on your energy bill. All delivered in a simple package designed to reduce environmental impact. Sounds great, right? Because residential buildings currently account for approximately 20% of the United States' total greenhouse gas emissions. And energy retrofits are expensive and complex. It's time to rethink our approach. Luckily, Realize has a solution. Realize, a Rocky Mountain Institute initiative and growing movement in the building sector, is driving a zero-carbon, whole building retrofit revolution by developing easily installed packages with built-in financing that improve occupants' comfort and transform building energy use across the country. How does it work? These pre-optimized retro kits include technologies such as prefabricated facade panels, efficient heating and cooling systems, insulated roof panels with solar and electric appliances, all designed to reduce construction time and reduce confusion through the design process. Tenants can even stay in their homes throughout installation. The result is a better-looking building that operates with zero emissions. To make this vision a reality, we're working alongside building owners, state governments, architects, manufacturers, and housing agencies to catalyze an equitable retrofit movement, beginning in the affordable multifamily sector and then spreading to all residential buildings. Realize aims to accelerate building decarbonization by deploying affordable, streamlined solutions that make buildings healthier for people and the planet. To learn more, visit our website or reach out to us at realize@rmi.org and join in our movement to decarbonize U.S. buildings.
Thank you, RMI. We're looking forward to hearing more about that. Before we do, though, we're going to go into breakout rooms here. And so this is going to be a 5-minute session. And do try to get all the way around your group and just do some rapid fire introductions. And once you've done that, if you still have some time, then you can reflect on the video that we just watched. And we'll see you back in 5 minutes. Thanks. All right. Great. So this is the article, Passive House Week in Preview. We do one of these every week. We announce the week's podcast, which this week features Bronwyn Berry of NAPHN, really interesting conversation that Matthew Cutler-Welsh, the host of the podcast, had. We also announced that the FIAS design competition is open, and they just extended the deadline. So you have until October 19th to make your submission. We've got a bunch of fall conferences listed here. The South Pacific Passive House Conference is underway right now. The Passive House Maine Fall Forum, it begins next week and kicks off with a keynote on Wednesday at this happy hour. So that's pretty fun. And Plataforma PEP Conference in Spain, FIAS Hootenannies, the Passive House Canada Summit, the socials we've got, including Mark Wiley's BS Fridays. So check those out, and lots of great educational resources as well. So that is it. And I'm going to let somebody else take over so that I don't have some other bloopers.
Okay, I think that's back to me. Hey, I just want to note 4 facts that I think most of you know, but are really worth considering as we get ready to talk about retrofits. Fact number 1, there are up to 6 billion buildings on this planet, depending on the estimates you believe. And those buildings emit roughly 1/3 of global greenhouse gas emissions. Fun fact number 2, there is no scenario by which human civilization survives climate change without eliminating nearly all the greenhouse gas emissions from nearly all of those buildings. There is no other path. And we need to do this promptly. We need to do it in our lifetimes, the lifetimes of those of us on this call. Fun fact number 3, the money is here. The EU is investing billions. Canada has committed a couple billion. Even the Americans are talking about billions for retrofits. This is about to happen. Fact number 4, we know how to do this. And by we, I mean the people on this Zoom call, we, the wonderful nerds who have spent years immersed in FSRI calculations and all the deliciously geeky bits of Passive House. This is our moment. This is where the plot turns. This is where we, who thought up until now we were just the humorous sidekicks, but it turns out we're the misfit heroes the world needs at this moment. This is our St. Crispin's Day. Future generations of Passive House geeks will think themselves cursed they were not here in 2020 and 2021. They will hold their therm files cheap when we speak of what happened at the ramparts of retrofits in 2021. Now, like every hero's journey, we have two emotionally difficult tasks. Foremost, we have got to stop bickering amongst ourselves. The world is burning, literally. It really doesn't matter which flavor of Passive House we pursue anymore. And two, we have got to make new friends with those new weird species on the other part of the spaceship. We need people who can figure out how to persuade the owners of those billions of buildings to spend the money to do the retrofits. And we need friends who can help us streamline the delivery of what we know how to do. And on that note, please allow me to introduce Martha Campbell and Amy Egerter of Rocky Mountain Institute.
Thank you for teeing us up so nicely, all of you. Really appreciate that. So, hi everyone, I'm Martha Campbell, and I'm with Rocky Mountain Institute and leading our Realize initiative. I am going to share my screen with you here. Okay, so I'll kick us off with just, as the video sort of mentioned, right, we're working on trying to catalyze this net zero carbon retrofit revolution. I think many of you have likely heard of Energy Sprong, and our effort is definitely based on and inspired by Energy Sprong. And so, you know, this whole kind of movement started about 5 years ago when a group of us got together in Washington, D.C., and we had, you know, Ron and Jasper from Energy Sprong come out and give this really inspirational presentation on what they're doing over in Europe with these standardized retrofit systems. And everyone in the room agreed, like, we just need to stop being incremental and eking out a little bit of efficiency here and there and just take these things all the way to zero. So fast forward 5 years, and we've been able to raise some resources to start a program to launch net zero carbon retrofits for the affordable housing market here in California, which is where Amy and I are based. So just want to give a kind of quick shout out to our team. We're sort of a big group. As I mentioned, we were awarded a grant.
Trying to get all the cars to go back to self-driving. It's not gonna fucking happen.
Hey Martha, I'm gonna mute everybody, and you're gonna have to unmute yourself, okay?
Okay, sure.
Yeah.
So as I was mentioning, we were awarded a grant from the California Energy Commission, and our team consists of the Association for Energy Affordability, who's really helping us kind of implement a series of pilots that we have underway, which is what Amy's going to talk about later. Energy Sprong obviously has been working with us from the get-go, but we also have San Francisco Department of Environment, UC Davis, Integral Group, and David Baker doing, you know, the engineering and design. California Housing Partnership Corporation is helping us with the finance and sort of regulatory and policy aspects of the project. Prospect Silicon Valley is also helping us with kind of sourcing emerging technologies and different kind of startup partners. And then Stone Energy Associates is also working with us on some of the policy and financing elements. And then, of course, Passive House Institute US has worked very closely with us on developing the standards, the retrofit standards and guidelines that we're developing for this form of construction. Just to kind of tee up exactly what are we doing, you know, that video was really nice, but what does that mean? What are the brass tacks of this? And, you know, we're not going to try and reinvent the wheel. This is basically the sort of market intervention model that Energy Sprong recommends, but I'd also argue that if you look at most corporations, they are doing some element of these 4 activities. You know, they have a pipeline for generating business, that's the demand side. They are producing a product and organizing their value chain to deliver that product. They are aware of sort of the policy environment in which they work and when it's conducive to their business models and it's not, and they work to influence it. Some of us might not always agree with their methods in doing so. And then there's a finance element. How do you make your product accessible and affordable to a customer. And I think, you know, we've seen finance streamlined and package financing be a part of everything from, you know, buying a car. You can basically walk onto a parking lot of new cars and walk away in an hour or two with a new car, right? And you never even opened your wallet. So all of these elements are a part of creating a market transformation and making it easier for for consumers to basically adopt what we're recommending, right? And that's these net zero carbon retrofits. So we are acting as an organizing entity and trying to basically go to different geographies across the US to enable this model. So Amy and I basically today are going to cover two main areas of this wheel: the finance section, which I'll talk about here briefly, and then Amy will dig into the supply side, which I think is where most of you will, the wheels will start to turn for you and ideas will emerge. So the first thing that we have to do, like I said, is to make this something that is consumable, right, by designing a financing model that works for building owners. As I mentioned, we're working with the affordable housing market segment. A really big barrier for them has been solving the split incentive issue. And we're very fortunate that here in the state of California, we have a mechanism called the California Utility Allowance Calculator that allows for owners to kind of recalibrate rents based on tenant energy savings and capture those rents and sew them into the project. And so the idea is that when we actually underwrite a much deeper level of savings and combine that with incentives, we can start to really get these projects to pencil and to enable projects to move forward. One other important thing to note is it's really important, obviously, to make sure that these things not only improve tenants' quality of life, but that tenants are also parties to the benefits of the savings. And so that's been a part of the financing solution that we're looking into. Now, kind of underscoring all that, or kind of the backbone behind the financing model, is ensuring the savings. And again, emulating the construct that the Europeans developed with Energy Sprong, is they divided performance risk into two components. There's kind of system risk of the actual equipment and performance of the building, but then there's behavioral risk. And so there's kind of two sets of contracts that the Energy Sprong model uses. It's a performance contract with ongoing maintenance and monitoring that what we're calling solution provider delivers to the owner. But then the owner also enters into a contract with the tenant where, similar to your cell phone plan, where you have a certain number of minutes every month, they have an energy budget. And if they exceed that energy budget, then they might be charged a little bit additionally by their utility for exceeding that budget. But if they stay within their budget, they do not incur any additional costs. And so the instrumentation and that monitoring equipment all goes into this integrated mechanical pod, which you're going to hear about later. I'm sure many of you have been talking, I guess, about the magic box. But that all kind of, most of it resides in that set of integrated systems and allows for the ongoing monitoring that enables this sort of performance model to work, and therefore creates a stream of cash flows that are guaranteed and can be captured by the owner. So these are the major elements of the finance side, and what we're still kind of in the weeds on kind of putting together. What that looks like, from an underwriting standpoint of kind of the different elements of an owner's capital stack. But I think this kind of gives you a sense of what we're working on the financing side. I'm going to hand it over to Amy now. We could have shared a lot more, but we want to keep it to 15 minutes. So I will stop talking and let Amy get into the technical details.
Cool, thanks, Martha. And hi, everyone. I'm Amy Egerter with RMI. And so I'm going to walk through more specifically some of our technical findings from the California grant that we've been working on for the past year or so now. But Martha was kind of talking about a one-size-fits-all financing program to make this program scale. And we really wanted to think about what are the variations of a retrofit package that we could scale quickly and easily across, the most prevalent building types in the state of California, multifamily building types specifically. So we did this typology study late last year on the 2.9 million existing occupied units, multifamily units in California, and tried to figure out, okay, what are the most common multifamily building types we could use to scale this thing. So we identified 3 different building types that would be a good starting place for us to work in. 82% of multifamily buildings in California are less than 3 stories. So low-rise multifamily is really the most prevalent typology you're going to see in California. Some kind of a low-rise stick frame building. Within that 82%, these 3 types are kind of the most popular or most frequently seen. So there's the townhouse, which is almost looks like single family, 1 to 2 story, 1 to 4 units kind of pushed together in the one building. And then there's a garden style, which is maybe 2 to 3 stories, but still exterior circulation, walk up units. And then the third would be kind of a bigger 3-story-ish loaded corridor prototype, where you have the interior circulation, whether or not it's conditioned is, sometimes conditioned, sometimes not, depending on where you are in California. But so this is really our starting point for, like, if we really want to hit scale with what we design, we need to design for these 3 building types. Looking a little bit deeper into, like, besides the geometry and like the physical characteristics of the buildings, what kind of systems do they have? We were able to get a lot of useful data from our partner, Association for Energy Affordability. They run the low-income weatherization program in the state of California, so they have a lot of insight into what kind of systems exist in these kinds of buildings. The smaller townhouse buildings, a lot of natural gas, gravity wall furnaces, sometimes central forced air furnace, a ducted configuration. In the Bay Area and in like coastal Los Angeles, you very frequently don't see any cooling systems, or you'll have kind of like one of those rooftop systems that you see on the townhouse image on the roof. And then domestic hot water for the smaller buildings is almost always in the unit, almost always natural gas as well. And then as you get bigger, there are some central configurations. Garden style, the systems look pretty similar to townhouse, just due to the size and the scale. And then for loaded corridor, as the buildings get bigger, there's some frequency of central steam and hydronic boilers with a radiator, but it's less common in California than what you might see in the East Coast or something like that. So next slide. So then, you kind of got the sense from this from our video, but trying to think within those 3 typologies, how can we make these technologies that are prefabricated, reduce on-site labor, reduce tenant disruption, and kind of form an all-in-one package so you can deploy. So there's the insulated facade panels in the Netherlands. They include windows and doors and are kind of hung on the existing building. So that's kind of the hypothesis that we're working with. More on that in a second. And then also insulated roofing panels that could integrate solar. And then kind of this magic box idea, we've been calling it an HVAC pod that can provide heating, cooling, and ventilation in one system. So it would have one heat pump that can do kind of all 3 functions, and then an ERV. And then electrification of appliances is also key. So yeah, I think, the target of this is just improve living condition, reduce energy expenditure, new construction jobs, and also reducing on-site labor. Not sure what that arrow is about. Go to the next slide.
I feel like somebody's whiteboarding.
Someone's annotating.
Yeah.
So anyway, going into, we have our building types. We know what we want to develop. We know kind of what the end state should be. And then we kind of set out on this energy modeling, engineering exercise to really figure out what those packages look like for those typologies. So we had, for the energy modeling, we had a preliminary set of specifications that were set using the FIAS guidelines. So we knew kind of what energy targets and load targets we needed to work towards with our packages. And then we ran a parametric analysis using Energy Plus based on typical values we were seeing from manufacturers for the roof panel, wall panel, testing double or triple pane windows, etc. We also tested this in 6 different climate zones in California, ranging from, you know, Tahoe area in the cold mountainy areas down to the desert in southeastern California. We then, RDH Building Science is a partner on a grant that we have to develop facade panels, and they assessed kind of what was structurally feasible for a facade panel, given the types of buildings we're looking at. So that turned out to be pretty limiting, but I'll talk about that on the next slide. And then we kind of consolidated that energy modeling, those energy modeling results for the different climate zones, what products were available from manufacturers, and then also what the structural criteria were dictating we could actually put on top of stick frame buildings in such a seismically active state. And we came up with the final retrofit packages. And so this slide illustrates, basically summarizes all of our major findings from this whole process. So right now, I'll just walk through kind of the typical flow of the decision tree. Right now, if you have a low-rise building, realize it is developing a product that can cover your building. If not, it's coming, but we don't have it yet. And so then the next question you really need to ask yourself is the building in need of a seismic retrofit? In working with RDH's structural engineers and looking at the California seismic code, we're finding that these buildings, because they're so lightweight, can only really support an additional 4 to 5 pounds per square foot of a facade panel. And just for context, the panels that were developed in Energy Sprong were about 8 pounds per square foot, around there. So we needed to get to about half that. And so there's some implications for what that means of how deep you can go on the facade, given that limitation. So just walking down the tree a little bit more, if you don't need a seismic retrofit, it then is just the question of, does your building have existing insulation in the wall or roof? If it does, our solution for that kind of a building, so, you know, it doesn't need a seismic retrofit, it already has existing insulation. The retrofit package that we would recommend is an R30 roof panel, triple pane windows, some air sealing, and then different solar heating coefficients for the building depending on what climate zone you're in. And so that's one avenue. If you don't have existing insulation and you also don't need a seismic retrofit, we were seeing the threshold of that 4 pounds per square foot really coming in at like an R8 to an R12-ish panel. We're still investigating depending on what kind of insulation you use and what kind of product. But an R8, R12 is kind of the threshold for that 4 pounds per square foot that you can get to without triggering a seismic or structural upgrade. Again, triple pane windows in some climates, double pane windows in others. And then you can get much better air sealing, we think, because you're rewrapping the whole building and you know, with panels and a roof and whatnot. Now, if your building does need a seismic retrofit, you can go full FIAS on this. So whether or not your building has existing insulation still matters, but your panel will need to provide some amount of seismic structural support, strengthening the building. But you can also get much higher levels of insulation here. And again, targeting 1 ACH50, and then because the walls are much more beefed up, just sticking to a double pane window, we think will be most cost effective. So those are the 4 major options we're working on right now. We're working with a couple of panel manufacturers to produce these types of panels and go through that R&D process. And then we have some other demonstration sites where we demonstrate the roof-only package. You can go to the next slide. So mechanical systems are a whole other thing that we're working on, and we also have a follow-on grant to work on this, the development of kind of an all-in-one system. But we, in the meantime, so there's kind of this end state of using a product like the Genius by System Air, which has an air-to-water heat pump that provides space heating and cooling. And Domestic Hot Water also has an ERV in there, I believe, and controls. So this is kind of the end state of what we want to get to. Energy Strong has used this product and others in their retrofits. And we have one unit that we're testing at UC Davis in their lab right now. But because none of those products are currently available or made to be sold in the US, we're kind of focusing on demonstrating quote unquote transition technologies that can combine 2 or more functionalities, so they can provide heating and hot water, or space heating and cooling and ventilation in one. So we're considering the Minotaur and the Chiltrix and a few others. And then down here are just some images of some of the control system we're looking at. And I think it's, yeah, so there's just a little bit more R&D that needs to be done on both the panels and the HVAC systems, but it's seeming promising that, you know, manufacturers from Europe and whatnot are feeling like there's a growing market in the United States to import these products and get them tested and certified in the state. And our demonstration sites, we're demonstrating on 300,000 square feet of low-income housing in disadvantaged communities in California. So we have 3 selected, and we're hoping to confirm our 4th, hopefully this week. So there's Veracruz Village, which is really the townhouse prototype here on the left. Murphy Ranch, which is in kind of the southern Bay Area, close to San Jose, more of a townhouse style. And then Beverly Terrace, which is in the northern Central Valley in Marysville, also more of a townhouse style building. And then this Veracruz Village is next to Bakersfield, so hot southern Central Valley. And yeah, we're really excited to be testing out the panels and some of our transition technologies for HVAC, and hopefully we'll be able to use one of the European products on one of these projects. So yeah, I think that's it for me. Super excited to hear your guys' comments and thoughts, and yeah, thanks.
Thank
All
you
right.
so much.
Great job. Sean, our question concierge, do you have some questions queued up?
Yes, so just before we dive into the questions, saw lots of great updates on people's awares that they bought a few weeks ago. We'll convert that to after hour discussions, but great insight and great stuff. And before we kind of geek out on the details, maybe focus more on the questions that are policy based, and maybe save some of the real, techie stuff to the after hour. So Lois, I'll let you kick off the first question. Lois Arena, are you there?
I'm sorry, I was trying to unmute myself. I was multitasking.
Focus.
What a shock.
Sorry.
Stop that.
Stop it. My question, there was a couple questions. One was, those climate zones are for California, right? And somebody said, yes, they were. Then my more substantial question was the weight, how much of the weight of the panels was attributed to a triple pane window?
Yeah, so we didn't actually get into, it's just the panel as a whole needs to be less than 4 pounds per square foot. And that 4 pounds per square foot is based on, I think by California structural code, the building can add 10% of its existing weight onto the structure without triggering a seismic or structural upgrade. And so we divided that 10% between the walls and the roof. Yeah.
I'm sorry, is it specific to seismic or is it other stuff? Is it shear? Is it?
I believe just seismic, but it's the structural code. So I think it's all kind of one. I don't know for sure, but
okay,
that was my sense.
Thank you. Thank you.
Excellent. Thanks, Lois. Rob, and then Chris. Rob Hoskin.
That was quick. Mine's kind of a technical question too, and it's just about the research protocol. And I was asking about what are the advantages for using Energy Plus to do the energy evaluation?
Yeah, this was actually kind of a sticking point because FIAS obviously does their calculations in WFI. We used Energy Plus because we need to make detailed models of the buildings just for other things that we're going to do in the project later on. So we actually worked with FIAS to have them calibrate the packages within WFI and come back to us and say, this package is a little bit off. this one should be a little bit different. And the other way, making sure we were getting to the FIAS load targets because they weren't directly translatable from the Energy Plus outputs to the WFE outputs that are published as the targets.
Sorry, I'm just going to chime in really quick. Amy, correct me if I'm wrong, but is it also that we wanted to make these guidelines accessible to the mainstream market where people aren't using WFE software?
Yeah, Energy Plus is a pretty widely used energy modeling software just for like standard building energy modeling if you aren't doing FIAS or whatever else. So, and it's also publicly available. So we thought that that would help designers as well. If they weren't so well versed in FIAS, we could translate those targets and they'd be more accessible.
Excellent. Okay. We've got Chris. You've got a couple of questions in the hopper. Ask one, and then I'm going to jump to June and then come back to the lineup because I think June's the first time question asker. So, Chris, you there?
Me?
Yes.
Yes.
Go ahead.
Okay. The first question is pretty much already asked and answered. The second question is, I'd be curious to hear more about the process of scanning the facades and generating a model and fabricating the panels. I know that was done in the Netherlands. Is that the same model that's proposed for the US version of this, or will it vary by availability of that technology or climate zone or building type?
Yeah, we're working on it. We're working with a professor at UC Berkeley, Avide Zakor, and she has a company called Signatron, and she has a DOE grant to work on the 3D scanning to BIM, to CAD, to CAM for the manufacturing files. So she actually scanned Veracruz, which was one of the building sites that was up on the last slide. She scanned it about a month ago, and we're waiting to get that 3D model from her on that. But yeah, it's something we're looking into. I don't think that the workflow exists as it does in the Netherlands to like here in the US, but so that's the point of Avide's research. Martha, I don't know if you have anything to add on that one, but.
No, I think that's accurate. And it's definitely a critical element for allowing for mass customization.
Yeah.
Great, thanks.
Thanks, Chris. June, you now have 2 questions. So start with your first one and we'll see where this goes.
I just wondered if you were marketing this program to the tenants or to the owner of the building. Something Martha said, it seemed like the tenants could capture some of the savings.
I would say that right now we're definitely gearing this towards the owner, right? For affordable housing for the to the owner, because the owner, ultimately drives decision making around a project for the whole building. Where obviously tenant engagement is really important is, and I try to avoid getting into the weeds on some of this because it's sort of not intuitive, but there's this thing called a utility allowance that is mandated by HUD. And if a building owner accepts low-income housing tax credits, there's this thing called gross rent, and your gross rent is equal to your rent plus your utility allowance. And the owner is required to leave the utility allowance in the pocket of the tenant so the tenant can pay their utilities. Those 2 things that add up to gross rent cannot exceed a certain percentage of their income. In order to be able to solve the split incentive issue, we need to reduce the size of that utility allowance and be able to turn that into savings that the owner can capture with increased rents. And so there is a lot of controversy in the, kind of affordable housing and sort of tenant advocacy community around the environmentalists prioritizing, the greenies prioritizing the environment and then basically leaving low-income families to pay the bill, right? And so we have to make sure that if we're raising their rent, that they're actually seeing a reduction in their utility expenditure. So that's why we need to ensure that they are a party to capturing some of those savings. It can't just all go to the building owner to be sewn into the financing for the project. I hope that helps. Like I said, I'd probably need to have a diagram and talk you guys through it a little bit more, but because it's counterintuitive. The owner is not capturing a utility allowance from the tenant. The tenant still pays their own utility, but it's regulated how much you can't charge past a certain rent when you combine rent plus that utility allowance.
Jean, you happy with that question? With the answer, sorry?
Yes.
Excellent. Okay, so June, her video is not working, but June, do you want to still come on and ask your questions? Give you 2 seconds and then I'll.
There we go. Can you hear me now?
We can. Yeah, go ahead.
I had two questions. One, I'm speaking from San Francisco, by the way. I had two questions. One was about other states, and I know that California has financial resources and often an outlook that makes it easier to be at the forefront of certain things. Do you have any experience with other states' approaches to this?
We're working in Massachusetts as well. We're trying to start up a program there. But we don't have anything that's developed to the level that it is in California. And we're still not totally developed, right? We're just getting started. I guess the one thing I just wanted to mention is, even though it appears that California is incentive rich, which it is through the low-income weatherization program and solar on affordable multifamily housing, the SOMA program, we actually cannot use those incentives and combine them with capturing tenant energy savings. And so it's actually like pigeonholing us to where we either have to work through the LIWIT program and SOMA, which only gets us to, roughly, I mean, it's still great. It's like it gets you to 66% reduction in energy consumption, but we can't get all the way to net zero carbon because those incentives require all the savings to go to the tenants. So this is the complexity that we're running into of the patchwork and myriad of incentive programs in California, that we can't combine them and stack them to get the projects to pencil because they are sometimes mutually exclusive to each other. So it's turning out it's not as rich of an incentive landscape as we had anticipated.
So there's no kind of umbrella organization or level that would enable you to, as you say, create really what you're ideally looking for. Is that right?
Not at the moment.
Not yet.
We're hoping we'll become that, or one of our partners will become that. Yeah.
Good. The second question I had was purely nuts and bolts, and I saw the image you put up of systems that are already being manufactured abroad, and I assume have been successful and do what they're meant to do. So what are the obstacles to having them come to the US? Are there policies that are in the way, like protection policies? What is it?
Yeah, I can take a stab at this one. Sometimes it's technical, like their voltage issues or just the way the electrical service is configured there is different from here, or something with the actual product design. Another big thing that we've heard from manufacturers is that they're just not sure if the technology will sell here, if there's a market for it. And then the third thing that a lot of manufacturers say is they don't know how they would maintain or service the machines once they send them here, because it would mean their company expanding into the US and needing to have, I don't know, operations maintenance staff here or people trained here who know their machines. So those are the three big ones we hear. It's been great though. We've spoken to Systemair, who's I think a Swedish company, but they manufacture that specific system that I showed in Germany, and they also have a factory in Kansas, I believe. But they don't sell that particular all-in-one product in the U.S. But because they have the U.S. arm, they were kind of like more amenable to figuring out how to export the product here. So that's how we got one of their products to test here. And then we also are working with an Italian company called Clevet, and they also make an all-in-one system. They have strong concerns about like serviceability and wanting to expand into United States, but they kind of were willing to give it a shot. So I think the fact that we're starting the program in California is sending like more of a clear message to them that we actually want these products. And also NYSERDA released a couple PONS, program opportunity announcements, or I don't know what the PONS stands for exactly, but funding opportunities to think about bringing the products to New York. So maybe between both of those states and other people asking, we can demonstrate more demand.
So do you get the hopeful feeling that just as with this issue, that is to say, just as with carbon dioxide emissions from cars, that as California goes, so goes the rest of the nation? In other words, eventually this will build and build and build and, fingers crossed, snowball?
I mean, I hope so. I mean, one thing I think is, and this is why the prefabrication component is so important. Like the cost of construction in California is so high,
right,
that I feel like, because a lot of people are like, why are you trying to salvage these crappy old buildings? Just tear them down and build them right from the start. But we're looking, you know, at a minimum of like, in the Bay Area, $600 a square foot for construction, right? For new construction. And so it's like, if we can get it to be half that, right? Like then you're going to need to retrofit, or, you know, so I think we can get it to less than that, by the way. But it's sort of a great place to start, because the construction costs are so high that if we can help kind of, you know, compress that, that construction cost, retrofitting does still make economic sense, even though it's still sort of expensive right now.
Right. Okay. Well, I don't want to hog. I have so many more questions, but I don't.
No worries, June. Stick around for the after hour. Again, great to have you. Great to have, again, a different person ask questions. So thank you for that. I just want to make one point in the chatter. And again, Brian, who's from Australia, again, this is why we have the Passive Accelerator Happy Hour, is because we can bring in people from across the planet to showcase this marbling efforts that Martha and Amy are doing, and hopefully you can learn faster and we can just copy and paste down there. So glad you're here to listen and learn about what these lovely ladies and their team is working on. Next up is Juhani.
All right. Thanks, Martha and Amy. It's very exciting stuff you guys are presenting. And it's really good to know there are people like you and Rocky Mountain Institute doing things in this country that are moving forwards instead of backwards. It's really encouraging. When I read the news every day, it's kind of forget that there's good things happening in the world too. So thank you just for that. And then I have a kind of a selfish question as an architect in New York that's looking to have a budding design build firm with my partner, Jeff, who's also on here, to do deep energy retrofits of single family homes in our Hudson Valley area here. I'm just wondering how, in a program like Realize California, and if something like that translated to New York, how would the rubber meet the road for people like us who would be, you know, we'd be excited to partner with a program like that and get certified or become kind of a go-to partner for the work. If an owner actually orders this stuff, it arrives on their site. Like, who's putting it in? Is there a big picture idea of how that works? Or is this kind of, we're not quite there yet?
I'll try this one if that's okay, Amy. So one quick thing is I highly recommend that you look at a company called Sealed. I don't know if you've heard of them. They're not doing passive house retrofits, but they are doing portfolios of single family retrofits in Massachusetts and New York, and they aggregate them together, and they are able to assume the tenant's or the owner, not the tenants, the owner's utility bill. So they pay their utility bill for them, and basically make money by kind of holding the owner's utility bill kind of equivalent or a little bit more expensive than what they were previously paying on their average energy bill. but then they get to capture the savings, right? And the incentives that come with it. So it's an interesting business model, but we've been talking to them and they're just not ready. I don't think the economics are there yet for them to be able to take the building to, you know, all the way to zero. But we've been trying to get them to work in the multifamily space, and they're not quite able to expand to that market segment. Bottom line is, take a look at them. In terms of delivery models, that is one of the things I feel like has been missing a little bit from the conversation. Everybody wants to talk about pilots and demonstration projects and the technologies. But when it boils down to it, when we talk about demand aggregation, we talk about scaling this, like the numbers that we need to hit to meet our climate action goals are around 3 million retrofits per year in the United States alone, right? I mean, unless we just tear all the buildings down and start from scratch, which we just talked about is kind of cost prohibitive. So we need to retrofit these buildings. 3 million, that's a lot, right? When we compare it to like our 1% retrofit rate through utility programs. Okay, so that means we need companies that know how to like plug and chug at this scale. Like, I don't even think there are that many new construction starts a year. I could be wrong about that, but it's like, it's at the same level of new construction starts, right? So it's an entire new market segment, in my opinion. So I appreciate you saying that, and we're working with the Association for Energy Affordability to kind of be that delivery agent here in California for the affordable housing market segment. But the rest of, you know, the owners market segments are like completely wide open space. Or, I mean, if somebody beats AEA to it, then fine, like we'll be happy that they were successful. But this delivery model for ongoing scale is something that we could use every single one of the people in this on this call to help us start deploying. Like we can't do all this on our own. We're like, you know, slogging through like trying to come up with like one retrofit panel and, you know, trying to get a magic box over here or something.
Mm-hmm. All right, so just sign me up somewhere. I guess that's what I'm requesting.
Okay, I've been already bugging Tim McDonald. I saw him on here earlier. I was like, Tim, you've just got to do this.
Yes, and Tim is second in the queue, so hopefully Tim will stay because I want to get his questions. But that's it. Top of the hour is over. Zach, let's wrap it up and dive into the after hour.
Yeah, great. So I want to start by asking, can you see this screen that I'm sharing?
Yes.
Yay! All right.
Yes.
Awesome. So I want to start my brief segment here by thanking our sponsors. So everything that the Accelerator does is thanks to the support of the companies that you see on the screen here. So thank you to our founding sponsors, Baxnagui Architects, Mitsubishi Electric Train, HVAC US, RDH Building Science, StoCorp, and Zola Windows. Thank you also to NYSERDA, who is our stakeholder partner. And thank you to our patron sponsors, Morrison Hershfield, 475 High Performance Building Supply, and Partel. Next week, we are going to have a keynote kickoff for the Passive House Maine Fall Forum happen here at the happy hour, and that will be by Susan Jones. So don't miss it. It will be great. And then the week after, we're going to be doing our third Passive House Component Spotlight, and this one will spotlight Partel and Hugh Bariski, who is the founder and the technical director at Partel, and he will be presenting about Partel's smart technical system for airtight buildings. So it's going to be a 15-minute deep dive into the building science, followed by a bunch of lively Q&A, very much like our call tonight. Thank you.
Thank you, Zach. We are the home of the 15-minute deep dive, a phrase that I would have found silly only a year ago. Thank you so much to Rocky Mountain Institute for that fantastic presentation. You know, I actually want to just follow up on one of the comments that I think is worth reflecting on. Someone asked really thoughtfully, you know, is this going to take off in California and scale to the rest of the country? A few years ago, I was really fortunate to work with Passive House Institute on some committees for retrofits in Europe. And what I learned there was that the rest of Europe hates energy sprung and doesn't think it works for them. Energy sprung works great in Holland, where they have a whole lot of buildings that were built right after World War II. in a view certain patterns. And I think what we saw tonight is going to work great in California. They looked at the archetypes in California. They looked at the structural limits and the seismic limits and the market rates in California. And they're doing the really hard work of figuring out a solution that works in California. I expect it'll be a different set of archetypes and a different set of solutions, say in Massachusetts, certainly in New York State and others. And I guess where I'd leave this tonight for our tribe of nerds here is wherever you are, maybe look for people like Martha and Amy and think about who else we can pair up with to start the work of figuring out what the local solution is everywhere. We actually sort of don't have time to wait for California to figure it out or any place else. We need to start concurrently on lots of different approaches in lots of different places, and we'll just keep talking about it and learning as we go. So thanks so much for the presentation. I urge everyone to think about kind of how this works in their climate zones with their construction technologies. And Prudence?
That's funny that you should say that, Monty, because I've been walking around my little new neighborhood here in Philly, like poking my head into these places where the workmen are. And I'm like, how are these things put together? These stone, there's wood, like what is, you know, absolutely figuring out, cracking the nut for what's in your neighborhood, because it all needs to get done. And to the extent that any of us can sort of specialize and become experts in certain typologies, depending on what scale we're working on, we need all of us. Thank you, both of you ladies, so much for the amazing work that you're doing. And we hear you that you need help. And I have a question that we can get to later in the after hour about more exactly how this community can help. And with that, let's roll on in to the after hour.